Hi, everyone, and thank you for joining us. I know it's been a few months since we've been here as the OWASP Nova team, and I am glad that you all are back. So, without any further ado, I'm going to introduce the panel of the Paranoids speakers. So, first of all, we have my fellow OWASP leader and moderator, Sean Porras.
Hey, everybody.
Thank you, and we'll start bringing in the team itself. So, we have Namita Pingle.
Hi, everyone.
Anders Beitnes.
Beitnes. Hi.
Beitnes,
Good to be
sorry.
here.
And lastly, we have Nate Burton. And as Sean, oops, sorry.
Hey, everyone.
And as Sean is going to be the primary moderator, I'm going to jump out of this and handle things in the comment section. So again, if any of you have questions or anything like that, shoot them out in the comment section and we will get the team of experts to address your container questions.
Awesome. Thank you so much, Ben. Hi, everyone. I am Sean Porras, and I am your host for today. You may know me as one of the board members of the OWASP Northern Virginia chapter, alongside my excellent fellow board members like Ben and Abdullah Munawar. But I also have a day job as Yahoo's leader of our cyber resilience unit for the Paranoids, which is our information security team. Yahoo owns some iconic brands like Yahoo Sports, Yahoo Finance, Yahoo Mail, AOL, TechCrunch, and Gadget, our advertising stack, and more. We have managed billions of accounts over the years, and we're excited to talk about container security at scale today and bring you our panel conversation titled, What's in the Box? Packing Essentials for Your Container Security Journey. We have some great folks here today from the Paranoids, and you've just got to know them a little bit, but let's get to know them more, starting with Namita Pingle.
Hi, everyone. I'm Namita Pingle. I lead the 3C security team within the security organization at Yahoo. 3C stands for Cloud, Container, and Compute Security. And I've been with Yahoo for 11 years and have been in my current position for 3 years. I was one of the core team members that built the cloud security program at Yahoo, and now I'm the leader of the team maturing the container security program. So that's really exciting. And outside of work, I enjoy doing Indian classical dancing and playing board games with my kids.
Thank you. Welcome, Namita. Next up, we have Anders Beitnes.
Hi, I'm Anders. I'm a senior principal architect in the Paranoids at Yahoo and a container subject matter expert on Namita's team. I started in software engineering at Yahoo and moved to security pretty quickly, where I've been for 12 years, which is an absolutely fascinating place to be. I love taking apart complex systems, seeing how they work, figuring out how to make them do things they aren't supposed to do, and figuring out how to keep that from happening. I love doing this with engineering architectures, so security is a natural fit for me. Outside of work, I like doing MacGyvering type of things and just trying to apply technology to different places and repurpose things.
Super. Thanks, Anders. And finally, we'll wrap up with Nate Burton.
Hey, everyone. I'm Nate Burton. I'm a principal technical security engineer on the Paranoids, working with Namita and Anders. I'm helping build and design the cloud and container security architecture at Yahoo, and currently focused on container build time and runtime monitoring. I have a background in infrastructure and cloud architecture. I've built large-scale distributed systems and started an on-prem private cloud with OpenStack, where I previously was at the National Security Agency for over 17 years. Where I spent a lot of time fighting bureaucracy, improving systems, and empowering developers within the government. In my spare time, I like wrenching on old European cars.
I was joking earlier that if you spent 17 years in NSA, you must have started work at age, 6 or 7. So welcome, Nate. Welcome to the panel. Before we get started digging into the security of containers specifically, let's orient ourselves around the definition of what is a container. So Anders, can you help get us started?
Yeah, at the core, a container is a pre-built image containing software, file systems, and so forth, running in isolation on top of the host OS. One of the key differences between virtual machines and containers is that virtual machines contain a guest OS in addition to the application, And the hypervisor isolates both of those from the host OS. Containers make calls directly into the host OS's kernel, so they're lighter weight compared to VMs, and they use fewer resources. So for containers, the analogy I like to use is prepackaged microwavable meals. They're much quicker and easier to prepare than cooking them from scratch. So some of the use cases containers are really well suited for is operating efficiently at scale. Containers are basically crops, they're not pets. If you have problems, you don't need a patchy container. You just plow them under and replant with healthy containers. Containers work well with orchestration frameworks. We use Kubernetes, which facilitates things like auto-scaling, blue-green deployments to pull in to new releases. It also makes DevOps more efficient. Containers are easy to deploy and facilitates splitting application into microservices, which allows you to make changes to the application without having to redeploy everything. It also works well with infrastructure as code, which is a very common pattern with the cloud vendors, and allows better utilization of computing resources. So, for example, you could have a workload running on a computer which handles your web traffic during the day, and then you start up some containers in the evening that do batch processing at night. The way you build containers is, there are a couple of different ways you can do it. You can build them yourself, preferably in your CI/CD pipeline, or you can pull them from a container registry. So there are private registries, there are public registries, and I think of public registries like getting prepackaged meals from the store. So I've talked about what containers are and why they're useful. So how does the deployer limit the blast radius when containers go bad? So the basic technologies used for containers are namespaces to isolate that process from the underlying host OS. So things like namespacing networks, namespacing processes, and so forth. Also, using control groups to limit how many resources a particular container can use, so it doesn't take over and do a denial of service on the entire underlying host. Now, threats you need to worry about, because this does change the threat landscape. So some threats we worry about include supply chain compromise. You recall the prepackaged meal analogy? Are you buying prepackaged meals from a store you trust, or are you buying out of the back of somebody's car? You're going to worry more about one than the other. What happens if somebody compromises the registry that you use? Can they put something in there that's malicious? Also, how much do you trust the original producer of the image if you're using a third-party container? So SolarWinds, a very good example of a supply chain attack. If you have a compromised container, what user does the container escape as? Or, since we're containers talking to the underlying host OS, are there any kernel privilege escalations that it can take advantage of? You can have multiple containers on the underlying host OS. So can a container compromise other containers running on the same host? When you're talking about networking, can the container access ports that are open on the underlying host or other hosts in the network? If it breaks out into the host, can it get to other containers? And of course, you have an orchestration framework that you use to make deploying containers really easily. But what happens if that container is able to tamper with the orchestration framework?
Great. Thanks for that overview, Anders. I mean, we covered containers, covered some use cases, covered some threats. So clearly we must have strong engineers who are working on building and deploying containers. These are seasoned pros, so they'll be thinking about security all along the way, right? Why do we even need a formalized container security program? Namita, what are your thoughts?
Yeah, so container technology has been around for a long time. It's not new. However, the use of containers in the industry and at our company at Yahoo started increasing rapidly over the last few years. And with any new technology come new risks of security, like security areas where we need to have oversight. So we identified this gap, and it became clear that a focused security program around containers was necessary. So initially, within the organization, each team started to come up with their needs and their requirements for container security. And we had a program management office that managed these needs. However, some needs were overlapping with other teams, and certain teams were moving forward with their roadmaps, while certain teams were not moving forward as much based on their priorities. And having observed this, it became evident to our senior leadership that it would be beneficial and efficient for the org to have one team that will bring together the requirements of all these various security teams and drive the program forward consistently across the pillars. So we started, so it was our team, the 3C security team, that took on this responsibility. And we started collaborating with various teams within the Paranoids, including the risk team, the incident response team, engineering, analytics team, just to name a few of them. And we're still collaborating with them, and it's a continuous process. And essentially, the goal was to make sure that all the aspects of security are being considered right from the start. So that has been the foundation of why this program came about. And to provide a brief history on like where we started building the program in 2018 when we put together a set of initial set of requirements, security requirements. And at that time, the container infrastructure had started picking up at Yahoo, and our technology teams had started building, and they're still continuing to build containers at a massive scale for our major properties. And so, coming back to the program development, so although the program started kicking off over the last 4 years, we have been doing container security for a long time through security reviews and engagement with engineering leadership.
Thanks. You bring up great points here, Namita. I mean, there are efficiencies and visibility value into container risk management to be gained by having an established container security practice. Now, I know you've built a great program. Give us some more detail about how you went about it. What are the key elements of a successful container security program?
Yeah. So our program, we built it on three foundational elements: having a baseline in place, monitoring to provide security visibility, and then governance and compliance to mature the program even further. So diving into the first element, which is the security baselines, we have baselines currently for container technologies such as Kubernetes. And baselines are the minimum security requirements for the technology at hand. So we develop baselines based on industry standards such as CIS, PCI, and NIST. So what we do is we review the industry standards and we check on what is being used at our company, and we develop custom baselines based on our needs. So that's the first element. Going on to the second foundation element, it's essentially continuous monitoring. And to provide an overview of the breadth or the scope of monitoring, the main areas include monitoring for security misconfigurations, vulnerability scanning, and container runtime monitoring. And we have developed custom checks to monitor against our baseline for security misconfiguration assessment. And we have specific tools for vuln management and container runtime monitoring. So that's the second element. And then moving on to the third one, the third one is governance and compliance. So from that perspective, we provide guidance through security reviews. And security reviews are performed when new technology is implemented or if there is a major change in the way the technology is being used by our teams or the organizations within Yahoo. Additionally, we have started rolling out governance roadshows where we engage with key stakeholders and engineering leadership to drive forward the security requirements and the best practices that we have for container security. So we figured early on that it is important to engage with senior leadership and technology leadership so they understand the value of our requirements and then they propagate that throughout their organization. So those are the three fundamental elements of the container security program.
Thanks for sharing that. And actually, exciting news. We have our first question in. Ben, do you want to provide the question?
Sure, let's go. And there's actually two, because there's one that I thought of myself. But let's start off with Brian's to Namita. What is your favorite container vulnerability scanning tool?
Okay, so we have looked through multiple container scanning tools, and so far the favorite one I have is Anchor.
Okay. And then mine is, you mentioned how the security team drives the policies and the implementations. How do you collaborate with the needs of the other non-security teams, like the developers or infrastructure team? Do you have a security champion included within those teams who kind of mediates, or how do you ensure that you're both secure and able to meet your business objectives?
Let me grab that, because I think later in the panel, actually, I think Anders is gonna hit that. But if we don't hit that, well, please follow up.
Will do. Then I'm
awesome. Good question, though, Ben. You're setting us up, man. This is fantastic. This was not planned, folks.
Yeah, completely planned. Yeah.
All right. So coming back to what Namita just shared, baselines, monitoring, governance, and compliance. These really are foundational elements for a variety of security programs, not just containers. So a lot of good lessons to learn here. Let's move deeper, though, from the programmatic level, and let's talk about the life of a container itself in more detail. Nate, can you dig into that a bit for us?
Yeah, sure. So Namita just talked a lot about some of the foundational elements of the program, and so containers bring a lot of benefits, such as easy packaging, composability, delivery of applications. So we use containers across large parts of Yahoo for a lot of those benefits. But there's a lot of new aspects to consider when deploying containers that are specifically related to how the lifecycle of containers are different than traditional systems. So unlike traditional hosts and VMs, as Anders alluded to at the beginning, you're not really providing a lot of operational ongoing support and care and feeding, such as actively patching containers. Instead, containers are meant to be short-lived, rebuilt and redeployed often. So in order to manage this at scale, you need a well-instrumented CI/CD system, or at least that's a very good recommendation for how to do this at scale. That involves building a secure software development lifecycle program. So these are kind of the core steps of build, publish, deploy, and monitor. And I'll dive into each one of those. So at the build step, you're taking your code, your dependencies, and you're building those together, maybe running some tests against them to produce an artifact. In the case of containers, that artifact is typically a container image. So the practice here is kind of along the lines of the shift left security model. You want to have automation that lets you easily catch security misconfigurations, such as security baseline violations that Namita mentioned, compliance violations, or supply chain security violations like vulnerable dependencies. So there's a variety of tools that can help in this area, regardless of what specific CI/CD system you use, because they're all easily pluggable in to the framework. So as far as container image vulnerability scanning goes, there's a variety of both open source and commercial tools in this space. Some good examples of those are Trivy and Gripe as open source ones, and Anchor and Sneak and many more as commercial ones. So catching vulnerable dependencies at build time is especially important because it lets you be much more proactive about your security. It's no different than catching a unit test that failed in the build process. Developer can dive in, see the output, figure out how to correct it, push a new commit to remediate before that vulnerability or issue actually ends up in production. It's a lot harder, and there's a lot more work involved if you detect issues after they've been deployed and they're running in production. Another key and emerging area in container image building and security is producing a software bill of materials or an SBOM at build time. There are a bunch of tools starting in this area, but the primary one that we've looked at and many people in industry look at is SIFT, which is an open source SBOM tool. Essentially, the SBOM is a list of ingredients, all the pieces of software and dependencies and libraries that went into producing that artifact or container image, so that you can more easily find where a vulnerable package might reside and if your application is affected. And then also build time, you can integrate infrastructure as code scanning tools, things like Checkoff, Trivi, Kix, Bridgecrew, Whitesource, and more. So these tools integrate with various automation frameworks like CloudFormations and Helm charts and things like that, where those infrastructure of code configuration files define how your application and container is meant to be deployed. So you can look at security settings and things that might be in violation of any of those standard baselines. Moving beyond the build step, the output of that is that you're going to publish a container image. Ideally, you should have a centralized container registry that's private that you manage with internal to your company, where you can keep an inventory of all the container images that are used. You can have awareness of which ones are being used, make sure that they are being covered and addressed by whatever container vulnerability scanning tools that you have. So you have a known state of the security posture of those images. Another very critical piece here as part of the publish step is cryptographically signing the images that you produce. You do that at build time, and then you can verify that actually at the deployment step. There are a bunch of open source tools, Sigstore, Cosign, Notary, that all help you verify that no one has tampered with maybe a container image or the registry when you go to use that container. So moving on to the deploy step, you now have built your containers, you've tested them, hopefully you've produced a SBOM and a signature for your images, and now you want to deploy your workload. So within Kubernetes specifically, there's the concept of an admission controller. An admission controller allows you to perform pre-deployment policy checks so that you can either allow or deny a workload from actually running. So this is very important to catch any last-minute security concerns prior to a production workload spinning up. So using admission controllers, you can verify things such as if an image is coming from an approved registry, verification of those image signatures that I mentioned, policy enforcement checks about the vulnerability status or image scan status of an image. So you can check maybe for specific CVEs of interest that are critical to you, or look at denying workloads from running if they have a certain vulnerability severity posture within the image. And these policy checks can also be different based on the context of what sort of workload you're deploying or what sort of environment you're deploying into. You might have a much more loose set of policy rules in your development environment, but then much stricter rules in production. And so that helps you balance some user experience problems, right? When you're doing development, there's going to be a lot more churn, and you don't want to be beat down by like security policy checks preventing you from coming up with proof of concepts and testing your things. But certainly in production, that is much more important. So there are a variety of options for admission controllers. The Open Policy Agent Gatekeeper, Caverno, and then you can build your own custom admission controllers, or there are a variety of third-party admission controllers that integrate with a lot of those previous tools and other tools in the container security space. One last aspect of deployment checks is checking the actual configuration of the container workload itself. When you go to run a container, you define things such as the user that the container is going to run as, the permissions that the container needs to run, what sort of access to the network or to host resources does the container need. So these are all things that are very critical to the security of a running container workload. And it's very important to know of those at deployment time and to have policies that you rely on to protect your production systems. And so the last piece here is actual runtime monitoring of your container workloads. So you want to be able to have sufficient visibility and insight into how those containers are operating, what the behavior is within those containers, looking for things such as indicators of compromise, network activity or behavior that is abnormal or shouldn't be occurring based on what you expect to know of that workload. There are a lot of other things such as with containers being more cattle or crops, you don't expect them to live very long here. So you're constantly rebuilding and redeploying to update the app, to update and patch vulnerabilities that may be in those containers as they're discovered. And so you want to look at, while those workloads are running, how long has a container been running, or how old is the image that the container is running on? Because ultimately you want to make sure that those are in line with your company's policies around the lifetime of running containers, so that you can manage those. There's a lot of tools in the runtime space, some open source ones like Falco and Tetragon. Tetragon's a newly released tool using eBPF that looks at managing running containers. And then there are very broad suites of tools that do full security posture monitoring. So these are commercial products like CrowdStrike, Prisma Cloud, Lacework, and there's many others. And so to summarize, ultimately, there's a lot of topics in depth to building and operating a secure development lifecycle for containers, and we don't really have sufficient time to cover those in depth today. But if you're looking for more details, a great starting point that I would recommend is the Cloud Native Computing Foundation, the CNCF, released a Cloud Native Security White Paper, and that link will be provided, and that's a very good starting point.
Excellent. Before we dig into the next section, we already have some more questions. So Ben, do you want to do the follow-up to the last round of questions before we go to our next segment?
Sure. And it's going back to Nvidia again. What extra value does Encore bring over an open source library scanning tool like Sonatype or Whitesource? It's kind of a follow-up to the previous one.
Yeah, so when we looked at Anchor, it provided a lot of value for our organization at that time. And so essentially, one of the key features that we liked was that it can monitor running containers and compare it with the images that have already been scanned. And then it can tell us the discrepancies. So that's a good feature that we found. And then it has a good open source code and active community. So that is good. That helps us as well. And the scale at which it can operate, we figured it meets the requirements that we have. So those are the three main elements that I felt were good to go with Anchor.
Thanks, Namita. And hey, Ben, there was a link that Nate mentioned. Can you, if you haven't already, can you drop that in the chat?
Yeah. Sorry.
No worries. Thank you. Okay, so Nate covered the life cycle. We hit build, publish, deploy, monitor, a lot of OPSEC that has to happen. Let's get back to the container lifecycle, a little bit more detail, Nate. How might we go about handling the vulnerabilities and vuln management in this complicated ecosystem?
Yeah, that's a great question. Vulnerability management is obviously a very critical component to running like a security program across your company. So hopefully you already have an existing process for vulnerability management, and you probably already have tools to deal with traditional vulnerability management on hosts and VMs and things like that. There's also so many of those tools you'll need to look at tooling specifically for containers because they operate differently as kind of previously discussed. But like vulnerability management also involves a lot of other facets, doing red teaming, participating in bug bounty programs. At Yahoo, we run one of the world-class bug bounty programs in the industry, and that's very good for helping proactively identify problems. And partnering with the community as well of researchers and vulnerability folks. But specifically focusing on vulnerability management for containers, like it's really critical to address this at the software development lifecycle. The earlier on, the better. But the other thing is there's not really gonna, it's not often easy to find a single tool that does everything that you need. You might have a set of tools to manage traditional hosts and VMs, a different set of tools that manage your endpoint devices like laptops, and then you've got containers to add into that mix. So I think composability and aggregation of data is important, along with reporting and visualization and feedback mechanisms to your stakeholders. You want it to be easy and have as little friction as possible between your end users and the security folks. You want to have a clear partnership there together. But ultimately, with containers, because the container lifetime is much shorter and you have this constant dynamic creation and deletion of containers, you're going to have a lot of containers to manage. So managing vulnerabilities at that scale is also a different and difficult aspect. So you also want to look at different ways to approach vulnerability management. Like, you don't want to ticket every single vulnerability problem that you identify on every single container image that is built. So you want to focus on how do you really focus in on the real critical ones based on how exploitable they are and what their network exposure may be within your environment. And also look at ways that you can wipe out a whole bunch of vulnerabilities at once. So if you track the base image that your containers are built from, oftentimes people don't update the base image that they're inheriting in the from layer of that Docker file when you build a container image. If you're running an old base image, you're going to by default have a lot of vulnerabilities in that container image. So that's another good way to address this, is making sure and tracking that people are using current supported up-to-date base images, because that allows you to address multiple vulnerabilities all at once. But ultimately, like the full topic of vulnerability management is pretty big, and it might be a whole presentation in and of itself.
Yeah, actually, we might be seeding that potential future OWASP Nova talk, right? It seems we do need a broader ability to have top-level visibility and oversight of an enterprise-grade container environment that could have thousands, tens of thousands, or even, I think as Namita mentioned, hundreds of thousands of containers alive at one time. Anders, can you talk to us a little bit more about the governance aspect of containers?
Absolutely. So when you're operating at scale like Yahoo does, you really have to be able to deploy automated systems to handle this. You can't just rely on ad hoc queries or just talking to certain people to find out what you need. So there's certain components of this that you need to be focusing on. One is inventory. So what containers are you using and where they're deployed will help you identify the threat landscape in your company. Next is provenance. Who owns the containers? Which engineering teams are running them? And where did those images come from that are in the containers will help you when you need to respond to an incident. And Log4j is a good example of this. When you need to get a lot of engineering teams to update their containers quickly and do it at scale, all of this needs to be automated, and often engineering teams may have systems that you can basically use and repurpose or enhance to be able to provide these types of functions. Another part of governance is monitoring. So the monitoring agents need to be container aware. Are those agents actually deployed? Is there a centralized engineering team making sure that your intrusion detection, your vulnerability scanning is deployed where there are containers that are running? Is your intrusion detection and vulnerability scanning working correctly and aware of what's in the box? Is another key point to make sure it actually delivers data. Another part of this is container logs, so having a centralized logging data store that it gets delivered to. Nate talked about the container lifecycle earlier. Can logging handle the transitory nature of containers? In order to make sure that all these are in place, you need to have a compliance process. At Yahoo, we take a phased approach when we add new requirements that need to be, complied through governance. So typically what we do is we'll announce that we're going to be adding a new requirement, and we inform the engineering teams. Maybe we'll have dashboards that they can go to so that they can understand what their security state is with regards to this requirement. So maybe they can actually start making changes before we start the last phase, which is enforcing it and filing tickets. Of course, when we're filing tickets, we want to make sure that we're ticketing the true positives, because engineers really do not like being diverted from working on features.
That's great. Thank you for providing more information about governance. And so now we can actually dovetail a little bit back into Ben's question, where we say, hey, can a security function do all of this on their own? How do they engage and influence engineering across the organization to drive security smartly into the container lifecycle that Nate talked about earlier? What do you think, Anders?
Yeah, really, security is everybody's responsibility. It's not just the security organization. And making engineering aware of the security controls and issues that need to be addressed, what controls need to be put in place, is a key part of this. Engineers want to do the right thing. They just may not know what that is. And on the security team side, we want to reduce the number of tickets that we actually need to file. So in terms of awareness, it's really kind of a multi-pronged approach. One of the things we do is speaking. We talk to engineering teams. There may be cross-company committees. For example, there might be an operations committee that talks about, issues related to operations. There may be a architecture committee where all the architects in the company get together to talk about, issues in their particular domain. But it's not just limited to speaking. There are other communications channels. So blog posts are another one where people can go and read about the issues, what needs to be done. Your company probably has a instant messaging channel or set of channels. Different groups, different focuses will have different channels. Make sure that you're posting out to those also. So, in terms of talking about messaging, you also need to shape your message for each audience. Engineering groups, they're more interested in hearing what they need to do and how they need to do it. They're just looking for things that are very tightly focused on their role. Engineering leadership, absolutely essential to help prioritize resourcing for implementing these security controls. I found that different leaders have different styles that they actually like to process information in. So if you have a leader that's very much data oriented, make sure you don't put your data in the appendix. Make sure it's right out there, as one of the first parts of your presentation to that leader, so that they can go and look at it and process it and figure out what they need to do. There are other leaders that just kind of look for like patterns that match previous things that they've done, and once they kind of fit what your message, your challenge, and what you need them to do into their pattern, then they'll just start iterating on that and do the right thing. Another audience, which is really important, is the security organization. You want to make sure that the other teams in your security organization understand what needs to be done for security, for containers, but you want to make sure we all have a common understanding, and we all give the same message. You don't want one security group to give a different message about what people need to do than the other groups are. So it's really important to be aligned. And lastly, I talked about dashboards earlier. Like I said, engineers want to do the right thing. If they can see a dashboard that shows them their container-related security issues, they'll often take action on their own initiative, if they know what the issues are and how to fix them. And that, in turn, will reduce the number of security tickets that need to be filed, makes less friction, and just everybody's happier.
Thanks for that walkthrough, Anders. I think now's a good spot. Ben, I think we have a few questions to tackle, so can you dig into to what we've been hearing from the community?
Absolutely, absolutely. I'm going to ask these in reverse because there were a couple of build-offs of it. And have you seen any good tools for ingesting SBOMs to query later? So this could help with your log4j issue that you brought up earlier. And there's a follow-up to that in that, is there anything aside from, say, dependency track, which is really good for identifying this? And yeah.
I think I could take this one. So SBOM is still a very emerging field. So like people are a bit scrambling on how to do it and trying to figure out the best tools and formats to solve this. So what we have today may not be exactly what we end up with in the future. So take for example, SIFT, which is an open source SBOM tool. It has its own SIFT native JSON format, but it also supports SPDX and CycloneDX, which are other existing SBOM formats. SIFT is ultimately the tool that's used underneath the Anchor engine, which is what Numedia had mentioned. And Anchor does have tools that ingest and manage and search across those SBOMs. But there are other tools as well. Dependency Track is a good one. Maybe not as mature and as feature rich as what we want yet today, but I think it could grow into that. I think there's a lot of work that I've seen discussed in the community where that could be useful. There's also Grapheus, which is an open source artifact metadata store, which is very pluggable and modular. We actually use Grapheus internally to track our end-to-end kind of chain of custody and provenance so that we can track things from code and build to deployments in production and have full end-to-end traceability there. So SBOMs can be mapped to notes and occurrences within Grapheus, and then that could also be a place to look at.
Cool. Yeah, sorry, I'm trying to keep track of everything in the comments. Another question is, are build packs good for base image security? And it's a little bit more general, and so we're shifting away, but...
Yeah, I don't personally have too much experience using build packs, but from what I understand, it helps manage kind of so that only the core layers and parts of your dependencies and things end up in your built image and do that in a secure, automated way. So I think there's nothing that I've seen that would make build packs a bad option to go down. If that's something you're familiar with and it works for you, I think that's a great approach to go down.
Cool. Well, thank you. That's all I got for now.
All right, excellent. Thank you. So, okay, we're actually going to pivot here too, which is great. So we've set the table. We've talked about some key elements of container security, spinning your first one up, managing vulnerabilities, gaining visibility, runtime monitoring, creating a programmatic approach to container security. Now, panelists, let's peer out into the distance and looking out at the road ahead. Before we get to the next road sign, where are those potholes along the way we should be concerned about? And then looking far out onto the horizon, where is the road going when it comes to container tech? And I'll just open it up to the whole panel.
I can start. So I think there are some new Kubernetes features that I think are really interesting and will help solve some of the or help at least reduce some of the security threats that exist in containers. One of those is ephemeral containers, which is a new feature in Kubernetes 1.23 in beta. And it allows for you to attach a container to an existing running pod. And so the big benefit here is if you have a production workload and there's a problem or a bug that you're running into, you need to be able to debug that. Traditionally, what people would do is their production container images would also need to contain debug tools in order to be able to debug them when they're running in production. That introduces additional risk because the surface area of attack is bigger than inside that production image. In the event that somebody was able to exploit your application and gain access to the container, they would have potentially tools like curl or debugger tools that would allow them to download other tooling or laterally move. across your infrastructure. So ideally, you want your production images as lightweight as possible, yet you still want to be able to debug them. And so that's the big benefit that ephemeral containers bring, is you can have a very lightweight prod image that doesn't have any of those package managers or debug tools or network tools in it. And then you can attach a debugging ephemeral container to that workload to allow you to debug. So that, I think, is super powerful, and it'll allow people to follow some of the container security principles in an actual practical way. Another new Kubernetes feature that's exciting is the new pod security admission. This is a new component that's a built-in admission controller to Kubernetes, and it's a replacement for the previous pod security policies, or PSP. So this also came out in Kubernetes 1.23. So this allows you to implement a lot of those policy enforcement checks at deploy time directly in Kubernetes, in your cluster at the namespace level. And there's predefined standard levels of what you want to allow, from like least restrictive to most restrictive. There are already predefined policies. You just enable them in your namespace. And then there's different modes that they can operate in. So they can operate either in a hard enforcing mode, or they can do audit or warning. So providing feedback to users, or allow you to warn rather than block, so that you can enable them in a phased approach and not have a horrible user experience as part of doing that. I think those are two things that I'm really excited about.
Yeah, I think that network still has a way to go to be fully integrated with pre-existing technologies and cloud vendors. There are service meshes and CNIs, such as AppMesh and Cilium, being deployed. AWS AppMesh is the only service mesh that I know of that supports AWS security groups natively, and I would like to see more support for vendor network security controls in the future. Also, eBPF is very promising technology. Very interested in seeing how that develops.
All right. Go ahead, Namita.
Yeah. So one thing I think, like looking ahead for the future. So with the technology now heading to the cloud, we should prepare ourselves to handle container security in the cloud. So one of the aspects that Anders just mentioned, so that's one of the things, like thinking about network security in the cloud. How are we going to monitor for that? How are we going to monitor for vulnerabilities in the cloud registry? How are we going to maintain an asset inventory in the cloud? And then are our on-prem monitoring solutions, are they going to be sufficient for serverless infrastructure in the cloud? So these are some of the things that we should be thinking about and identify solutions now, so that we can be prepared for the future.
And can I actually follow up to what Namita just said? I think one of the key areas there that we've focused on heavily at Yahoo is that there's all these security requirements you need to know, all of these checks you need to have built into your systems. And if you just leave the developers and engineers up to their own to do that, it's really hard, and you're going to get a bunch of different solutions, and a lot of them aren't going to be very secure. So what we actually do is we have partnered with our engineering teams, platform engineering teams, and rather than people rolling their own Kubernetes, we have either managed offerings or cloud offerings that are very opinionated and have all of the security aspects of them built into them from the get-go. So making sure that your Kubernetes API isn't accidentally exposed to the internet, ensuring that some of these admission controllers and scanning and lifecycle management things are addressed, feeding into logging and other systems like that. Like having that pre-built stack that's optimized for your company's deployment model and security policies, I think is really important to provide people guardrails so that they can be empowered to go build and deploy their applications in Kubernetes.
Yeah, I totally agree, Nate. And when I look at the approach that you just described, I think that's a fundamental approach that every security program should take, and have this vision statement of, maybe I'll never ticket. Why will I never ticket? Because I've enabled the engineering teams up front to be doing things right off of the shelf. Right now, we'll never get there exactly, but it's a nice vision to think about. So that was great. Thanks for everybody's prognostication about where things might be going. We have one last question before we wrap up. I can't believe how quickly this went. What excites you about container tech? What got you interested in containers in the first place? And what's your favorite thing about container security? Maybe Namita, you can start us off.
Yeah, so with container security, I'm excited about it because I'm getting to learn a lot. And also, since the technology is emerging, like now it's picking up speed, we are learning and maturing with the technology. So that's something that fascinates me. And then we have an opportunity to contribute back to the community to mature the technology further. And the panelists here, Nate and Anders, are the key members who contribute back, and that really excites me.
Yeah, so I come from a background in product security, and I'm interested in containers because of my fascination with complex systems. I also see real opportunities to help developers by providing security guardrails in the secure development lifecycle as well as governance. Nate was talking about it just a minute ago, and that in turn is going to reduce friction for developers, make it easier for them to build secure containers, which in turn helps our users to be safe, which is really the key goal behind all of this work.
Yeah, I think for me with containers, like I got into them kind of for personal reasons. It made my life easier because it's easy to package things up, put it in a container, do some prototypes or experiments, and then throw it away when you're done, and you haven't like unnecessarily cluttered up your laptop with a bunch of software dependencies that are lying around. And so that's very useful. And then from that, I've just use them more and more. But I'm also interested in the areas where Yahoo's scale, our internet presence, and some of the problems that we have are also applicable to the broader community and how we can share and contribute back. Some examples of that are we actually open source something called Athens. It's a service identity system similar to Spire, if you're familiar with Spiffy and Spire. It supports the Spiffy spec, and it allows you to dynamically grant service identities to your containerized workloads, do authentication and fine-grained access control, and we've integrated that with Kubernetes in our environment. So I think that's exciting for me.
Thanks so much for sharing your thoughts on what excites you about the tech. And to everybody out there in the community, thanks for your time today. I hope the story of the Paranoid's container security journey in our chat gave you some new ideas, maybe reinforce what you were already thinking about, or otherwise helped you on either your own career journey or the container pathway at your current company. Thanks again to the OWASP Northern Virginia chapter for having us here today, to Ben Pick and Abdullah Munawar for their ongoing leadership and help today. And finally, thanks to my fantastic panelists, Namita Pingle, Anders Beitnes, and Nate Burton. I've been your host, Sean Porras. We have enjoyed this conversation, and we do have a little bit of time left for Q&A. So Ben, I'm not sure if any other questions came in, but we would be happy to field them if they're around.
Sure. There aren't any in the chat. I believe we answered everything, but there are a few that were messaged to us earlier. What are some of the ways to handle situations where distributions choose to remediate package level vulnerabilities? I don't know if that necessarily applies. I think they were sending me that question before they really fully got the topic.
I can take a stab at that. Being fairly familiar with operating system distros specifically in the Linux and container space, CVs come out. These distro providers take open source packages and they package them up into a distro, and they manage the versions and backporting any security fixes and provide a very managed release process for end users of those distros. Each distro is slightly different, and so some are going to be more bleeding edge, following latest versions. Some of them are going to be more risk adverse and have a nice balance there. Things like enterprise Linux distributions from like Ubuntu LTS or like Red Hat Enterprise Linux distros along those lines. But it usually comes to be that there's always CVEs out there that a vendor for one reason or another won't fix. And it seems to be pretty common across all of them. If you ever look in the CVE database, you'll find scanning tools spitting out a CVE for a particular container image or a host. And then you'll go to the vendor distro website and like, hey, there's no fix for this thing. And so it's a problem you'll run into often. Many of the container scanning tools specifically actually have features that allow you to not output vulnerabilities for which there are no fixes available. And so that's useful to help cut down on some of the false positives to manage that.
Yeah, and kind of extending this to containers and container images, for example, you might be using Alpine as the base image for container you're building. The crops, not pets paradigm fits really well here. So all you basically need to do is, either rebuild it, maybe put your own patches on there if you need to, create a new image, and then plow the old containers under and plant new healthy ones.
Yeah, that is one of the nice benefits of containers is that like you can fairly quickly take your application and put it in a completely different container base image, build it upon a completely different container base image, switch from Alpine to Ubuntu or Debian to CentOS or Stream or something like that. And your application should work very similarly. And that is another approach too, is if you need to, in certain cases, migrate from one base image distro to a different one.
Yeah, and I talked earlier about blue-green deployments. This is really that process that the orchestration frameworks make really super easy to do, where you just rotate out your old version, rotate in the new version. It's super easy, and you can do it at scale.
Cool. And then there's another follow-up to that same question, but I want to give one last chance for anybody to ask questions in the chat. And if you missed your chance, or if you're watching this on replay, do you mind if I put your Twitter handle, the Paranoids, in there, and then they can directly ask you something as they think of it?
Sure, why not?
Okay, then yeah, I'll throw it right in there. And part two of that previous question is: do you think those distributions like Debian are unworthy of use in production enterprise environments? Do you think we need to segment them off and then, do you think we should segment them off so that they aren't automatically pushing these package level changes instantly into production as the new versions come out?
Well, I think you always want to have control over those. You want to have your own repository that you control so that you can determine when these things get pushed in production. You basically need to have change management for containers, just like you do for the underlying, host OSs. But I think this is like something that pretty much all distributions, this is like a characteristic that all distributions share. And it's really up to you to determine what's acceptable, what your risk appetite is, and decide how you're going to approach that risk.
Yeah, I would agree with that. I think there's it's kind of a company level decision as to like what distros you want to support and allow in your environment, and that's a very risk informed decision on your part. Containers make it slightly easier to move across them, as I mentioned, but another thing is having well-defined policies around what operating system versions you support in terms of like making sure you're tracking end of life software. So there's a lot of old operating system distros and versions that are no longer being maintained, and there are no patches for those things. So that's a very important thing to track as well.
Yeah, so that's a really good point. So you probably want to have an allow list of versions that you actually allow in production. And this allow list is actually going to change fairly often. Like, was it CentOS 8 went to CentOS Stream? And that's something where maybe every 30 to 90 days, you want to be revisiting your allow list and just making sure it's up to date. And then using that as part of the governance process to make sure that versions that are not supposed to be in production are actually removed from production.
And then switching to a completely different topic, this looks like it might be the last question. How do you feel about pinning deployments to a digest? And if you do, how do you keep those pinned deployments fresh?
I can take this one. So pinning deployments to a digest is a very good practice because it ensures that you are going to get the container image that you expect to get. Because that digest is based on the cryptographic hash of the manifest and the layers involved in that image. And so there's often, you'll see if you go look at container security guidance, like don't use the tag latest, especially in production, because somebody could build a new version of that image, push a new version of that image to the same latest tag, and then what you thought was going to be a particular version ends up being a new version. And in many cases, that might not be a malicious action. That might just break something that you're expecting. But in other cases, that could actually be somebody trying to exploit that by timing that version tag overwrite to catch you off guard. So it's good practice to pin both dependencies and container image tags to a digest in very specific versions, because it'll ensure you are operating off of a known set. There's a lot of dependency confusion attacks out there where people will take advantage of things like that, where if people haven't pinned their dependencies, that can put them in a bad spot for exploit.
Well, thank you so much. There aren't any more questions in the chat. So I just want to say thank you, everyone, for joining us in this episode. If you're catching a replay, if you were live, I really appreciate you all watching this content. It was really informative. And thank you to our speakers, Namita, Anders, Nate, you all were wonderful. And thank you for coming on here. We hope to have you again. And Sean, as always, it's fun hanging out and got to watch you and sit back a little bit. And I appreciate you managing and monitoring and asking the right questions. And one last thing, I did want to update the Twitter handle for any additional questions is SKP000. That's Sean's. So if you have any follow-up questions, feel free to message him instead of going through the paranoids. And we haven't finalized the details for next month's talk, but we will hope to iron those out and get back to a more regular monthly schedule. I do apologize that it's been 3 months since our last meeting, but we will see you all soon. So Take care.
And if anyone has any great ideas for future talks, let Ben, myself, or Abdullah know.
Yes, please.
Right. Thanks, Ben. Thanks, everyone.
Have a good night.
Thanks, everyone.
Thank you. Bye-bye.